The new small block V8 engine is RPO code LS1 and features an aluminum block and heads. It displaces 5,665 cubic centimeters or 5.7 liters. The firing order is 18726543. The bore and stroke are 99 and 92 millimeters, or 3.90 and 3.62 inches, respectively. Power ratings for the applications are found in the reference booklet for this course. Before we look at engine disassembly, let's take a closer look at the LS1 V8 engine. One of the first things you will notice about this engine is the coil near plug ignition system. It uses individual ignition coils and short spark plug wires to deliver more spark energy to the spark plugs. The lightweight composite intake manifold reduces heat transfer to the intake charge. The manifold positions the port fuel injectors to target the intake valves for more complete atomization of the fuel. The tall intake ports in the cylinder heads enhance injector targeting. Here is the actual port and flow path to the intake valve. The aluminum cylinder heads use replicated intake and exhaust ports. This means that each intake port is the same as the other 7, and likewise with the exhaust ports. Combustion variation between cylinders is minimized by this port configuration. The valve angles are set at 15 degrees to form a shallow combustion chamber. The valve head diameters are 50.80 millimeters, or 2 inches for the intakes, and 39.40 millimeters, or 1.55 inches for the exhausts. The valve springs are conical, or beehive in shape, allowing for a lighter spring retainer. The roller rockers are made of investment cast steel with a 1.7 rocker ratio used to actuate the valves. Moving on to the engine's lower end, here we see the aluminum deep skirt block. It incorporates cast iron sleeves that are cast into the block during production. In addition, the block uses enclosed lifter bores under each cylinder head. This design provides a stiffer structure and quieter operation over an open valley design. Cylinder heads are attached to the block using 4 head bolts per cylinder. The thread bosses are located deep in the cylinder block to minimize cylinder distortion at the top of the bore, maximizing ring seal. The rigid deep skirt block utilizes cross-bolted main bearing caps. Each main cap is retained by 6 bolts. The thrust bearing is located at the number 3 location to reduce the expansion differences between the cast iron crankshaft and the aluminum block. You'll also notice holes through each of the bulkheads. These holes improve crankcase ventilation at high RPM. The crankshaft is cast from nodular iron with journal diameters of 65 millimeters or 2.56 inches for the mains and 53.33 millimeters or 2.1 inches for the rods. Each journal incorporates rolled fillets for increased strength. Center drilling through main journals number 2, 3, 4, and 5 decreases weight and improves crankcase ventilation at high RPM. A reluctor wheel for the ignition system is pressed onto the rear of the crankshaft. The LS1 uses strong, lightweight cast aluminum pistons with low tension rings and forged powder metal connecting rods. The connecting rod cap is separated during the manufacturing process using the fracture method. Connecting rod center-to-center length is 154.90 millimeters or 6.098 inches. The roller camshaft features large journals that measure 55 millimeters or 2.16 inches. The cam lobes have a large base circle relative to the lobe lift, which helps to reduce valve train loading. The hydraulic roller lifters are retained with unique glass-reinforced nylon guides. Now, on to the lubrication system. A crankshaft-driven gerotor oil pump provides oil pressure to the full-flow lubrication system. A large pickup tube delivers unrestricted oil to the pump under all conditions. Oil is supplied to the main and camshaft bearings simultaneously through a parallel priority feed arrangement. And lastly, we'll look at the engine's cooling system. Coolant follows the conventional flow path, passing through the block first, then the cylinder heads, and finally through the outlet to the radiator. Positioning the thermostat on the inlet side helps eliminate thermocycling. A coolant vapor port located at each corner of the cylinder heads eliminates vapor pockets for enhanced cooling efficiency. Additional information about the features of the LS1 engine can be found in the CPT booklet that accompanies this video presentation. In this segment of the presentation, LS1 disassembly is examined. We will only concentrate on what's new compared to the other engines you've experienced. Before beginning, it's important to note that when disassembling the engine, internal components must be separated, marked, or organized in a way to ensure reinstallation to their original location and position. This is because the components will develop specific wear patterns on their friction surfaces. Be sure to separate, mark, or organize the following items: pistons and their piston pins, pistons to their specific cylinder bores, piston rings to the pistons, connecting rods to the crankshaft journals, connecting rods to the bearing caps, crankshaft main and connecting rod bearings, camshaft and valve lifters, guides, push rods, pivot supports, and rocker arms, valves to valve guides, valve springs and shims to their cylinder head locations, engine block main bearing cap locations and directions, as well as oil pump drive and driven gears. The composite intake manifold is designed for operational efficiency and simplified service, as no coolant flows through it. Removal is straightforward. The captured gasket O-rings are designed for easy replacement. Whenever manifold service is required, the gasket O-ring should be replaced. When servicing the coil near plug ignition system, do not remove the spark plug wires from the coils unless coil service is necessary. Ignition coils are serviced individually and are interchangeable. Captured gasket technology also makes valve cover service quick and easy. The rocker arms for each bank of cylinders are mounted on pivot supports and are attached by individual bolts. Before cylinder head removal, the coolant vapor pipe must be unbolted. When you remove the head bolts, use a circular pattern starting from the outside working toward the center. The larger head bolts are torque to yield or stretch bolts and cannot be reused. The roller lifters require cylinder head removal for service. However, the lifter guides make removal and installation of the lifters a snap. Knock sensor service is accomplished by removing the intake manifold to gain access. However, with the knock sensors being located in a dry hole, no coolant needs to be drained. The valley cover and single-piece gasket seal the top of the engine. The cover also provides structural integrity for the block.